The world has just gotten over Endgame fever. I think we are safe from spoilers, but here's your heads up if you haven't seen the movie yet. Okay, those of you that are still here know that the film works around time travel, with Tony Stark solving the problem of navigating the quantum realm thanks to information provided to him by Antman. They travel back and find the Infinity Stones. In doing this, they splinter the universe, with Captain America even going back and spending a lifetime with his love, Peggy Carter. This is just a fun-filled Marvel romp, a big blockbuster movie filled with superheroes and no science, right? Well, actually, we may be closer to having the capabilities that was showcased in the film, with the recent discovery that a newly developed quantum computer can see the future. There may not be the 14 million futures seen by Doctor Strange, but it does see 16 of them. So let's take a look. Welcome to IF, videos on history and mystery. Hit that subscribe button and ring that bell so you never miss a video again. Let's start by asking, what is quantum computing? Is it an alternate universe technology like is seen in the movie? The fundamentals of the ability of a computer is to store and manipulate information. Current computers manipulate individual bits, which store information as binary zeros and ones. Quantum computers leverage quantum mechanical phenomena to manipulate information. To do this, they rely on quantum bits, or qubits. In a quantum computer, a number of elemental particles such as electrons or photons can be used. In practice, success has also been achieved with ions, with either their charge of polarization acting as a representation of a 0 or a 1. These particles are qubits. The nature and behavior of these particles, as expressed in quantum theory, form the basis of quantum computing. The two most relevant aspects of quantum physics are the principles of superposition and entanglement. Think of a qubit as an electron in a magnetic field. The electron's spin may be either in alignment with the field, which is known as the spin-up state, or opposite to the field, which is known as a spin-down state. Changing the electron's spin from one state to another is achieved by using a pulse of energy, such as from a laser. Let's say that we use 1 unit of laser energy. But what if we only use half a unit of laser energy and completely isolate the particle from all external influences? According to quantum law, the particle then enters a superposition state, in which it behaves as if it were in both states simultaneously. The particle can move in a superposition of many different states all at the same time. This is when a kind of time travel comes into the picture. Researchers following Iron Man's lead used the quantum quirk to design and build a prototype computer that can predict 16 different futures all at once. When Mal Ju, our equivalent of Tony Stark, boots up his newly designed computer, he gets to see the future, well, at least 16 possible versions of it. Ju, an assistant professor of physics at Nanyang Technological University in Singapore, is an expert in quantum computing. The science uses the weird and bizarre laws that govern the universe's smallest particles to help computers calculate more efficiently. We can look at the well-known example of Schrödinger's cat and the thought experiment that says that a cat trapped in a box, making no sound or movement, is simultaneously dead and alive until the point that someone opens the box. A qubit in a superposition is similar, as it can equal both a 0 and 1 until it's measured. This means it can store multiple different outcomes in a single qubit, this ability making it more efficient in terms of memory compared to traditional computers. This giving it a distinct advantage when making complicated predictions. In a study published on April 9th in the journal Nature Communications, the professor and his colleagues demonstrated this idea using a new quantum simulator that can predict the outcome of 16 different futures, the equivalent of, say, flipping a coin 4 times in a row in a quantum superposition. These possible futures were encoded in a single photon, a quantum particle of light, which moved down multiple paths simultaneously while passing through several sensors. Then, the researchers went one step further, firing 2 photons side by side and tracking how each photon's potential futures diverged under slightly different conditions. The computer specialist then went on to make the comparison to the Marvel Universe, saying, "It's sort of like Doctor Strange in the Avengers Infinity War. Before the climactic battle of the film, the Doctor looks forward in time to see 14 million different futures, hoping to find the one where the heroes defeat the big bad. He does a combined computation of all these possibilities to say, okay, if I change my decision in this small way, how much will the future change? This is the direction our simulation is moving forwards to." So they have a working Eye of Agamotto based on real-world physics and not the mystical energies of the movie world. The researchers tested their time stone, or quantum prediction engine if you prefer, using the classic model of the perturbed coin. The professor explained, "Imagine there's a box, and inside it is a single coin. At each step of the process, someone shakes the box a little bit, so the coin has a small probability of flipping. Unlike a traditional coin toss, in which the outcome always has an equal chance of being either heads or tails, the outcome of each perturbed coin toss depends on the state the coin was in during the previous step. If the coin flipped from heads to tails during the 3rd shake of the box, for example, then the 4th shake would be likely to remain tails." It sounds like we need the Ancient One to offer the professor a bit of warning like she did with Bruce Banner when he got his big green mitts on the time stone. The researchers ran 2 different versions of this experiment, one in which the box was jiggled a little more strongly and another with less powerful shakes. In both experiments, the box was shaken 4 times, providing 16 possible combinations of outcome of heads and tails. Following the 4th step, the team encoded its superposition of all 16 outcomes into a single photon, a qubit, simultaneously showing the probability of every possible outcome based on the strength with which the box was jiggled. The team then, in the final stage of the experiment, combined the superpositions of the strongly shaken coin and the weakly shaken coin to create one master map of possible future outcomes. This showed us how quickly the futures diverged depending on how hard I shook the box at each step, Joe said. Today, constraints on computing power keep the team's simulator limited to looking at only 16 possible futures at once. But the professor claims that this limitation is only temporary, and that one day, as quantum computers become larger, more powerful, and more commonplace, simulators like this one could be expanded to see infinitely more futures all at once. He says that there are many practical uses for this technology beyond defeating large purple space villains. It could aid in weather prediction or help make more informed investments in the stock market. It could even help improve machine learning, which is all about artificial intelligence teaching itself to make better and better predictions. So, we step from Endgame and into the world of Age of Ultron, Aeon quantum machines able to see the outcome of every event. That's going to work out well. He added, "This is all highly exploratory and will require lots of further experimenting to figure out all the quantum simulators' applications." Have we just witnessed the first steps to predicting the future? Will this computing power unlock the secrets of time travel? Would you like to travel in time? If so, to when would you go? Let me know in the comments below. If you like what I do here on the channel, hit that red button, like and share. You can catch the latest by searching We Are If. Thanks so much for watching. See you next time.